Let's say you're a super genius 9-year-old, and you're really good at making digital circuits, but you've got a very small budget. And let's say you're mostly frugal, right? So you're normally in the positive, but once in a while you're gonna have to owe some money to your mom. So let's just say, just bear with me here, that this is a plot of your finances over time. This is zero. Anything below this is means you owe money. And let's say maybe to start out you might and then you had to spend some stuff to buy something, buy some parts, buy some chips. And so the thing I want you to notice about this is you only borrow maybe at most $2 from your mom, right? You only borrow $2, and the rest, is all going to be positive, right? Wow, it's really faint. Right, everything above that is going to be positive. And let's say we're dreaming big, and we know that we're going to have big positive budgets. We're talking in the tens of dollars. That's a lot for a 9-year-old. At least it was for me. So we're making a system that can hold our current balance, let's say. And we're in this situation where we need to be able to have negatives and positives because sometimes they're going to be in debt. But we don't really need that many negative numbers because we know. Let's just say that we know we can never go more than $2 in debt. We can never go more than $2 in debt. And so it doesn't actually make sense to do a system that gives us just as many negatives as positives. And so in this case, it might actually make sense to use excess notation, in which we can define our system to fit exactly our situation. So if we know that we're never going to go greater than -2, right? We'll say that this is -2. What we can actually do is an excess 3 system. So this 3 here, this is our bias point. And what that's saying is this is the binary sequence. 3 is the binary sequence that represents our 0. So that's this guy right here, right? This is our bias point. 3. So what can we do here? Well, we know that our bias point is a 0. And now our rules of excess notation is any sequence greater than our bias point is a positive number, and they increment in the proper way, right? They just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And we stop when we get to a sequence of all ones. And look at this. It looks like I actually screwed up. I should have just did an excess 2 number system, because if we look at how many negative numbers we're going to have, which are all the sequences that are less than 0, 0, 1, 1, I have -1, -2, -3. So maybe we've got some provisions in case we borrow $1 from Dad as well. So here, let's retcon this. There we go. I was never wrong. All right. So yeah, if we kind of cut this up, right, a lot of our systems we had like a straight line for where our negatives and positives were. But now we've just got this very narrow little slice that is negative, and the rest of them are positive. So that said, let's figure out what properties, and I'm not going to write them down, but I'm just going to kind of go from memory here. So what properties could we have? Well, do we have a single zero? Yeah, we've got a single zero. It's right there, just that 1 0. Do we have a clean zero? No. In this case, we don't have a clean zero. The only way we could have a clean zero is if we had an excess zero system, right? If 0, 0, 0 was our zero, in which case that would just be unsigned numbers, where there would be no space for negative numbers. So let's write that one down, no clean zero. Okay, so what's the next one? Do we have a full range of values? Well, yeah, we do. Each one of these sequences represents a unique number. So that's good. And are we, what is it? I can't remember the exact term, but as we go around this, do we increment properly? Well, we start at our minimum, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, all the way to 12. So this increments nicely, and we also have a clean rollover. Excess notation always has a clean rollover because our max is always going to be right next to our min. So this is actually the only problem that we have with this system, is there's no clean zero, right? No clean zero. So that means it's actually reasonable to do math with excess notation. You just have to remember that all of your bits, they're offset by 1, 1. And so you have to have some special provisions when you're doing math with excess notation, but it can be done.